Hey, physics kids, this is Mr. Dahlin here. I'm just compiling all your emails that you're sending to me, and I'm going to create a video here today for you to help with all those questions that were asked. I real quickly want to talk to you about video learning and online learning and how that, a couple of hints that are going to help you. First off, when you look at the description of my videos, I'm going to put in the videos descriptions of what we're going to cover and what times it is covered on the video. This video is going to cover more than you might need, and you don't need to watch the whole thing. So be looking at those descriptions, figure out what part of the video you actually need to watch. Also, another hint, when you're watching a video to make it go faster, increase the replay speed. Okay, so watch it in like 1.5 time or double time. It'll go faster. And then when you get to something that you think you missed and you need to hear it, you can then go back on the video and slow it down and rewind until you get to that spot again. So just a couple of things are going to help you with that. Especially more and more classes are going to be, online just in general. But for us specifically, with being out of school for at least a month and doing everything online, that's going to be really important for you. Okay, so I'm going to look at today. I'm going to focus on our lab for Wednesday, April 1st and Thursday, April 2nd, specifically related to the power of the launcher and how that affects the range. So Cannon Fire Power Lab. And specifically what we're going to be looking at are 4 things. We're going to look first off at what do you actually need in your data table. Just from what I've been seeing on the last lab and from some of the questions that some of you have been having, some of us are confused on what should be in your data table. Some of you had way more information in your data than you actually needed, and your graphs on the last lab were awesome. Some of them were not actually what the lab was looking for. And the whole point of a graph is to make all of your data in one picture, and that picture should then show you the pattern that we're trying to find. That's all experiments are. They're trying to say, okay, if we change something, what else happens? And is there a pattern that we can see there? And it's that pattern that's important. So if you have the wrong information in your data table, you're not going to have the right pattern. And so I need to make sure we see that. Second thing we're going to be looking at is how do you then set up the graph? Some of you are mixing up your X and your Y axes and what should go where. So we want to make sure we're looking at that. Third is how do we do this, creating a data table and then also doing your graph in Google Docs. And so I'm just going to show you how to modify that picture that's on the lab sheet. To be honest, if you just wanted to make a graph on a piece of graph paper, download a piece of graph paper from anywhere online and then print it and then do that on there. Take a picture of that graph and then upload that to your file. That works too. In fact, that might be easier or faster, but I'm going to show you how to do the Google Docs way, because the reality is Google is really commonly used. It's free, and so a lot of businesses are using it. It's pretty powerful. It does a lot of things. And so just having good skills with Google is going to be really helpful for you. It's just a general life skill. So I'm going to show you that. And then the last thing, I'm going to show you, a lot of people had questions about the conclusion section, specifically like what does it mean with the X and the Y intercept stuff. So we're going to look at that. Again, look at the description, figure out which of those you actually need help on, and then you can fast forward to those other parts that you don't. Okay? All right, so first thing, how do we know what should go in our data table? And that all comes down to what are the variables that we're looking at. So we've done a bunch of variables. We kind of have this theme of firing something out of a cannon. On today's lab, we're looking at the power setting. How does the power setting of the cannonball or whatever it is you launched, how does that power setting affect how far it goes? And that was our research question. How does the power of the launcher impact the range of the projectile? Okay. Now, something to be aware of when you look at the simulator, it doesn't actually have power. It has velocity, right? Initial speed. Now, what we have to kind of keep in mind is if you have the same object, but your cannon is able to fire it at a higher speed than it did before, it had to give it more power to do that. So that's kind of taking the place of our power settings that we had on our launchers. Okay. Okay. So now think about that though. That research question is also telling you what data you need to measure and record. Okay. When you read that research question, what are the 2 things you need to have in your data table? Read it. You need to have a power, or in this case, velocity number, and each velocity number needs to have a range number associated with it. That's it. That's all you need. Okay. You don't need to have a height. Okay. You don't need to have the arc. All you need is what was the velocity that was set at and what range did it go to. Everything else is a constant. We don't care about it. Okay. So as you're going through then for your procedure, when you create your data table, those are the only 2 things that need to be in there. So I'm going to go to the lab sheet real quick. Okay, so here's our lab sheet. You hopefully fill out all of this information. You got your research question. We need to make sure we know which of those is the independent variable and which is the dependent. Okay, so in general, change the colors here. In general, the independent variable, I always said I for independent. I, as the experimenter, I change the independent variable. Okay, or you are changing the independent variable. So I for independent. What are we changing? We are changing the power, which is really a velocity. And we want to look at, okay, well, what units does it have? Okay, well, look at the simulator. What units does it have? Meters per second. So I want to make sure I have that. That's really important information to know, that your speed is in meters per second. It's not miles per hour. It's not inches per year. It's not, kilometers per day. It's meters. How many meters does it travel each second? Okay. And then the dependent variable, remember the dependent variable is what you as the experimenter are looking for. When we change the power, okay, when we change the velocity, what happens? The what happens part of that is the dependent variable. So the other thing that we're trying to measure from our research question was the range. Okay, that is the dependent variable then. So the range. Again, we need to know what units does it have on the simulator. So go back to the simulator. And I looked, okay, I got meters here, this thing, it doesn't have anything on it, but my tape measure that we can use is all in meters. Okay, so that's important. Our units then are meters. It's not centimeters, it's not miles, it's not feet, it's not inches, it's meters. Okay, so we're gonna skip all this other stuff because hopefully you got that. The diagram, procedure stuff, make sure you get those filled out. I'm looking for that, but make sure you have that. We're focusing right now on this data table. Okay, so what should be in the data table? Only 2 things were velocity and the range. Insert a table. Okay, again, let's get used to using Google Docs, Google Spreadsheets. The more useful you are with using those, the more valuable you become in different things. So we're going to insert a table. I only have 2 things that I'm measuring. So I only need 2 columns. And notice this kind of highlights as I expand out, right? I only need 2 columns. And the lab does say you need to have 5 trials. Now, I don't want to have 5 rows. I actually want to have 6. Here's why. The top row, I want the top row to be my title, my header. What am I measuring here? That's important. If somebody else is to look at your data, your results, they need to know how to interpret it. So usually, and this isn't too important, but usually the thing that you are changing, the independent variable, usually goes in the first column. Okay, so independent is again the velocity, and then the dependent usually goes in the second column. So in this case, it's going to be the range. And then make sure you record what are the units that you have in there. Okay, And then I know that my velocity can go from 0 all the way up to 30. Now, we only need 5. Okay, doesn't matter which 5. Oops. I like to go by even increments, meaning having it change by the same amount each time. So here's one thing that you need to be aware of. 0, a lot of time is very important. So I'm actually going to have my first velocity be 0. And then I'm just going to go by 5 each time. So I'm going to set my second one to 5, my third one to 10, my fourth one to 15, and my last one, my fifth one to 20. And all I need to do is use the simulator to figure out these numbers. Make sense? Okay, let's do that real quick. So here's 0, right? I'm going to launch it and watch my cannonball. In this case, it's a pumpkin. That goes straight down. Now, this thing right here, which is originally up here, that's really useful for you. If you put that right on where it lands, make sure the height is at 0. That will tell you the range of your projectile. So range of 0. That makes a lot of sense. If it has no speed when it comes out of the cannon, it's just going to fall straight down. So range of 0. Okay, now I'm going to do 5. So increase, get this out of the way so you can see it. Increase my speed to 5. And again, you can pick any numbers here. This is just what I did. Okay. Launch it, watch it go, bring down my tool, and now I record. Okay, range of 5.53. Again, the height needs to be at 0. If the height's anywhere above, it hasn't landed yet, that's not the full range. We're looking for how far is the range when it lands. So, a range of 0, and that is, excuse me, range of 0, 5.53 when the height's 0. Okay, so that is my number that I put here, 5.53. Now I do 10. Again, if you don't need to see this, feel free to fast forward. I'm just trying to show as much as I can here, trying to go kind of quickly. Okay, so 11.06 meters is my range. So I put that in here. Now I'm going to do 15 for my velocity. Launch it. Ooh, I almost hit the target. Okay, 0 and 16.59. 16.59, and then my velocity of 20. So I increase this to 20, and I launch it. Bam. Okay, height of 0. My range is 22.12. Okay. Now, that's my data. Okay, that's all for part 1. Some of you need to go back and look at yours and see if you actually did something that is related specifically to velocity and range. If you have anything else on there, you don't need it. Okay. If you wanted to put like an extra column to have like trial 1, trial 2, you can do that stuff. But for this one, that's not going to be on the graph anyway, so it doesn't matter. Okay. Now, on the graph, that's the second thing we're going to be looking at. Okay, setting up the graph. The graph only should have the information in your data table. The whole point of a graph is to make your numbers here, which look kind of messy to most of us, that makes it a little bit harder to see the pattern sometimes. It makes it into a picture because our minds understand pictures better than our minds understand numbers. And that's the whole point of a graph. Okay? That's why we use them a lot in science, we use them a lot in math, we use them in economics, they're used all over the place because it makes complicated numbers easier to understand. So, how do we do that on Google Docs? Well, if you click on your picture of the graph there, that is a picture, which means on Google Docs you can edit it. So I'm just going to double click. Okay, something happened there. So what we're going to do is we're actually just going to insert a drawing. Okay, just make a new drawing. And I copied the picture of a graph here, so I'm going to put that in here. This is actually the same graph that you had in. So what we're going to do, I'm going to actually shrink this up just a little bit. Now, nice thing about this graph, it has 20 squares on it, which is partly why I picked a velocity from 0 to 20. If you didn't do that, that's fine. I'm going to show you for the range how we do that. Now, important, going back to our PowerPoint here. Where those go on the graph is important too. Okay, so scientists try to have a lot of things just making sure we are consistent. And what they said somewhere in the past is that the dependent variable should always go on the y-axis. And again, remember the dependent variable is what you measured. It's what you looked for each time we did the experiment. The independent variable goes on the x-axis. And again, the independent variable is what I, as the experimenter, changed. I changed the power or the velocity, and then that caused the range to do something else, and that's what I'm looking for. So the range is going to go on the y, and the velocity that we launched, it's going to go on the x. Okay, so I'm going to go through there. I'm actually going to add this little box up here, adds a text box. I'm going to add a text box for my titles. We want to make sure we have titles on everything. So the title is velocity. Oops. The units also need to be on there. I'm not going to put it snug up to the graph because we're also going to have numbers. Every axis needs numbers. Okay, and I'm going to do another one here, and that one was the range, which was in meters. If you want, you can tip it or twist it like this so that it's sideways. I kind of like doing that. That's just me personally. Okay, then I'm going to add another text box, and we're going to start putting in numbers. So every box here for the velocity, there are 20 boxes if you count them, which means I can have a one box represent 1 meter per second. So I always want to make sure I put 0. 0 is always the origin there at the corner. And then every 5 boxes is going to be 5. You do not need to number every box. Okay? All you need to have is enough numbers so you know how much each box is changing by or increasing by. So I'm going to put on the 5th box, I'm going to put 5. And that actually is nice because it's also how much I went up by each time. And then I'm going to, on the 10th box, that's going to be 10 meters per second. So let's see, 5, 6, 7, 8, 9, 10. That one right there. And then on the 15th box, that would represent 15 meters per second. So 11, 12, 13, 14, 15, go over right to there. And then the last one should be 20. $17, $18, $19, 1, 2, 3, 4. Oh, I have them over one more on that. So 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, and then 20. So I always double check. Okay, now for the range. The range, again, I'm going to save and close this because I need to know what numbers I have for range. Okay, so what I'm going to do is I'm going to write down real quickly what my numbers are for range. I got 0, I got 5.53, I have 11.06, I have 16.59, and I have 22.12. Now, here's a problem for us. I'm going to double click on my picture again. 20 boxes up, I have a range of 22, which means I can't do one box, meaning have a scale of 1 meter. So I got to pick something else. So I'm going to actually pick 2. I'm going to go with easy numbers. I don't want to get real fancy, real complicated. If I have one box represent 2 meters, then I have enough boxes to go all the way up to 22 meters. And again, you do not have to number every box. You just do enough so that you know what the scale is. So I'm actually going to do every 2 on this one. 2 boxes. If one box is 2 meters, that means 2, 4. So there's 4 meters. Okay, and do another text box. 2 boxes up, so 6, 8. If each box is 2, then this one would be representing 8, or this line, I should say. And then I have 10, 12 for the next one. I have 14, 16 for the next one. And then I have 18, 20 for the next one. And then 22 and 24. And I don't need to go higher than that because I know my biggest number was 22. Okay, now, sorry, that's my daughter with her ice water. Now I need to plot the points. I'm just going to use dots. Okay, so I'm just going to use little circles. Is there a pumpkin? There's no pumpkin in here, so I'm just going to use circles. So at 5 meters per second, my speed was 5.53. So I got to kind of figure out, okay, where is 5.53? Well, here's 4. This must be 6. So 5.53, probably closer to 6 than it is to 4. And so I'm just going to put it like that. Okay, there's my dot. Now, you can change that however you want to. I'd recommend making them a little bit smaller, although this isn't maybe letting me do exactly what I want to. Anyway, okay, now I'm going to copy it and paste it. So I'm going to right-click, copy, and then if I click off of it and paste, right-click to get this menu, paste, that makes a copy of it. So I'm going to use the same one for my next data point. Oh, I forgot 0, 0, most important one of all. So there's 0, 0. That was my first one. Okay, now I can still paste, same dot. Okay, so my next data point was at 10 meters per second, and it was 11.06. So I got to figure out, okay, here's 8. This is 10. This line up here is 12, so it must be right in the middle of those. Okay, my next one, again, right-click, paste to get my dot. And my next data point was at 15 meters per second, right here, and at 16.59. So here, make sure you got the 4 arrows. Of course, now it's being tricky on me. Okay, so delete that, paste. So 15 to 16.59. So here is 16. This one must be 18. So 17 would be right in the middle, and 16.59 is pretty close to right in the middle of those two. So, there we go. Oh, no, that was for the graph. There we go. Get a little bit higher. Okay, so now it's a little bit above that. Okay, and notice I'm not being super accurate. It's okay. Okay, last one was at 20 meters per second and 22.12. Why these are not wanting to work for me right now? Okay, I'm just going to do this to make it bigger. Makes it easier to move. Okay, 22. So this is 20, 22 would be the one in between. Shrink it down so that it's the right size. Okay. And looks good. Now, that's your pattern. Now you also want to create a best fit line. Remember, a best fit line is either a straight line or a curved line that seems to match what the dots are telling you. This looks like it's pretty straight. So I'm going to go up here. I'm going to select a line. I'm going to start it on 0. Okay. And I'm going to just try to drag it and see if I can't get one that goes through all of them. And it looks like I can do that. Right about there. I'm going to increase the size of the line. So that's what this icon right here does. Change it to 4. That looks good. Okay. And then if you want to save some space, you can move your text boxes back in and get them a little bit shrunk up or closer. Okay, there's my graph. Now that's the second thing, setting up the graph. Okay. I save and close, now I have it. Okay, now again, going back, what are we talking about? Graphing on Google Docs. Okay, I just did it with dots using my data points. Last thing that we're going to look at is the conclusion section, and this is where a lot of you had some questions. The conclusion is constantly having you go back looking at the graph. So let's first talk about what is an intercept. Okay, an intercept, that is just math's fancy way of saying where does my line hit the x-axis and the y-axis? Okay, so on this graph, it only hits the x at one spot, 0. It only hits the y at one spot, 0. So this question is saying, does it make sense on my graph for the x and the y-intercept to be at 0, 0? How do you know? Well, think about what we did in the experiment. When is x 0? Well, that's when the velocity is 0. Why does that give a range of 0? That's what I want you to kind of answer. Think through that. Okay, so the x and the y-intercept is simply saying when one of your, in this case, the x-intercept is saying, hey, when your independent variable is 0, what do you expect that to have happen? Does your graph show that? The y-intercept is then basically saying, when was your dependent variable 0? Okay, and there's a lot of times where that information is really important. Okay, so going down, data analysis is kind of having you do some of that stuff. And then the conclusion. When it says for an every statement, make a for every statement that describes what your graph represents. That's basically saying, look at the line, okay, and say, what is the line telling you? Now, I'm looking at this. One thing you might want to do is find the slope. Okay, and remember, slope is just how much does the line go up by each time. And I'm actually going to look at the numbers here. It looks like, this is where 0, 0 sometimes is really nice and important. It looks like the range goes up by about 5.53 each time I increased my velocity by 5. So it's saying for every 5 meters per second of velocity, my range increased by 5.53. Now, if I wanted to get fancy, I could even go down to 1 meter per second. So if I know 5.53 divided by 5 is saying then for every, that's 1.106. For every 1 meter per second that I increase the velocity by, the range should increase by 1.106 meters. That's an example of a for every statement. A for every statement needs to include both the independent and the dependent variables in your statement. It's basically you linking them together. How are they related? That's the whole idea. It's the pattern. The research question is saying, if we change the velocity, what happens to the range? The for every statement is a way for us to do that with numbers. Okay? Then make a statement that describes what your intercepts represent. Okay? Well, to figure out x-intercept, you need to know what the units are. And that's why it's really important to have your graphs properly labeled. Your graph is x is your velocity. So what does the x-intercept mean? The x-intercept is when your velocity is 0. Do the same thing for y. What is your y-intercept measuring? Well, that is your range. That's why it's important to have those things labeled. So a y-intercept is basically saying when your range is 0. Okay? And then these boxes down here are basically saying, okay, make a claim about whether and how you could change the intercept for this lab. Okay? I want you to think about, if you want to play with the simulator to see if you can get that to happen, I want you to think about how you might change where this line intersects on the x or the y axis. Okay? Now, just because it's asking you to do that, the answer could be I change x, y, z, I change the height, I change the object, whatever that might be. It might also be you can't change the intercept. Okay? And when it says here, what evidence supports your claim, I want you to play with the simulator and see if you can do that. Okay? So that's what we're doing. And I think those were the questions that most people had on the simulator. So if you have any more questions, I know that was a long video. If you have any more questions, please email me, and I will try to get back to you as quickly as I can. Thank you for your patience with this distance learning stuff and going to online, and I hope this was helpful for you. Thanks.